Hello students, welcome back. We didn't complete anything, and I don't intend to complete anything. We went through problem 3 and we started problem 4. We got up to hypothesis setup. Here we go. No difference versus there is statistically significant difference, plot positive. And how do I know it's positive? Take the difference. 0.652 minus 0.577. This difference over here is 0.075. That's positive. Okay. Alternative is positive. Okay. Let's test hypotheses. And we talked about critical value method in a separate video, and there may be some students who would not want to look at it at all. So let's go over to probability value method. And it goes like this. Draw the picture, of course. And then centered at 0. Again, pretty natural because we are doing two-sample inference. So the default is 0, no difference. Unless the problem explicitly says the difference is 67 milligram or something like that. Unless the problem explicitly says so, you start from 0. Now, where do I put an end? Well, we calculated the difference, observed difference, is 0.075, and that's where we're going to put. Actually, if you do it a little bit more precisely, you're going to get 0.07497 something, and that's something I calculated from the raw figures, 158 versus 237, and 79 versus 237. Excuse me, no. From these figures, if you actually look up the paper itself, not the abstract, then it has a little bit more extensive table, and from there I got this table. I mean this figure, 0.0749 something. But for the purpose of mathematical exercise, we can start from 0.075, 7.5%. And that's going to be the end here. So you can find out this shaded part, the p-value. How do I do that? Z-score is end minus center over SE, and that is approximately equal to 0.075. 0, this the center is 0, divided by SE, which you calculated in problem 3. Problem 3A, you did it. So this is going to be approximately equal to something, and that something is a number you have to work out. Once you work this out, then you can use Z-table to figure out this p-value. And your problem, your trouble is actually just beginning. Okay, we did all those mechanically and then got the p-value. What do you do now? What's the conclusion? And if you understand the idea of conditional probability of committing type 1 error, rejecting the null while null is correct, or accepting the null while null is correct. And that's really difficult to consider because those are conditional probabilities. So I don't blame you if you don't really follow type 1 error, type 2 error, and all those things. So a bit of a cheating is this p-value you calculate is roughly speaking The p-value is the probability that null is right. So high probability that null is right, what do you have to do? You have to accept null. Low probability that null is right, then you'll have to reject null. Now, this description is not a correct description. Don't show it to any other mathematician. They're going to laugh at me. But I'm doing this only to help you. Most of the time, this works. Not all the time, because this is an incorrect statement, but most of the time it works. Roughly speaking, p-value you calculated up to now is the probability that null is right. So what do you compare that with? You compare that with alpha. Where's alpha? 0.05. And greater than this alpha, then high probability that null is right, we go with null. Less than alpha, then low probability that null is right, so we reject it. The detail and all the computation are left to the students, and I'll just show you the picture. If you do it right, the p-value will turn out to be quite a bit bigger than alpha value, so we'll have to accept the null hypothesis. No difference. No statistically significant difference. In short, remdesivir does not help.